Okay, welcome to day 5. Day 5 will be polar functions and graphs. So if you go back to your Algebra 1 days or pre-algebra, the first thing you learned was how to plot points on a XY axis or a Cartesian grid, and then you did some graphing of functions on that. Well, it's going to be the same thing. Day 4 was graphing points on a polar grid, and now we're going to actually draw some graphs. But we're going to use our calculator to help us out with a lot of filling out tables and actually what the graphs look like. So first thing we're going to do is go to our mode key. I'm going to change it to polar mode. The mode key is right here next to the blue second key. So here's the calculator, and right next to the blue second is the mode key. I'm going to hit mode, and you can see I'm in degree. Make sure you're in degree mode. But underneath the radian degree we have, well, we've probably been in functions mode. We're going to talk about parametric in a few days. Oh, we have this polar mode, and we actually could have done sequential mode or sequence mode. I just chose not to because it's not really advantageous to be in this mode, except for a few problems. So I come to polar mode and hit enter, and make sure you're in degree mode, which is good, and hit second mode, and you quit out of here, and now you are in polar mode. Next I ask, what happens when you hit the y equals key? Well, the y equals key is on the top left. So let's see what happens when we hit that y equals key on our calculator, and we hit y equals. It doesn't say y equals anymore, does it? It actually says r equals, and we can put it on all these r equations. And we'll talk about this little -0 thing. It's called the tracer. It's actually very good because it shows on the graph. So look, when we hit y equals, it doesn't say y equals anymore, it says something else. The next thing we're going to do is hit this variable key, the key that we've been using this whole time to hit the letter X. So the variable key is really right here underneath the mode key, and notice there's a bunch of things on there besides the letter X. So what happens when we hit that key on our calculator, and notice when I hit that key, it doesn't say X anymore, it says theta, because we're dealing with polars, which are going to be r values and thetas, not x's and y's. So instead of having y as a function of x when we're in function mode, we're going to have r as a function of the variable theta. So when we do all this, we're going to play with the calculator. We're going to do some examples. So we have r is a function of theta. Theta is still the input, r is the output, but we still plot points that are r comma theta, even though it's kind of still reversed. So we're going to try an example. Okay, so we're going to put this example into the calculator. R equals 8 times the sine of theta, and we're going to hit zoom, which is the top center of the calculator, and then 6, which is the standard window, -10 to 10 on the x and y's, and then we're going to see that maybe it just kind of looks weird. So we're going to hit the zoom square key, which is zoom 5, which will square up the grid so it looks more like what it should look like. And I'll talk about that special key also. So on my calculator, I'm going to get rid of this. I'm going to do 8 sine theta. I close my cursor, I close my parentheses. Now, just like before, whenever the equal sign is on, it is going to graph that function. Now I'm just going to graph it. I'm going to hit enter, and this is what I mean. You have different things you can do, different colors, but you have different things you can do. You can do the tracer, the normal thick line. So I'm just going to do this normal thick line, and now I'm going to hit zoom top center 6. Mine's going to draw fast because of my computer's a lot faster than the calculator. And look, it looks like an ellipse or an oval, but I don't think that's what it should be because the way the axes are, the x-axis is farther spread out than the y-axis. I'm going to hit zoom 5, which is going to square up the picture up, and look what we get. We get a circle. So we're finally drawing a graph that is no longer a function. This is a circle. So I'm going to go back to the calculator and show you how you can slow some things down a little bit. Go back to my y equals, and if you come over here to the far left and you hit enter, you can change the color if you want. I'm going to keep it blue, but See where it says line? You can do many things. You got a thick line, thin line. This little, looks like a -0, a -0. It's actually called the tracer head. It's going to draw the graph, but you're going to see that little 0 on the where it's drawing the trace of the graph. So I'm going to hit OK with this. Now I want to hit graph. You can see what's actually being drawn, and I think you're seeing that this is being a circle drawn twice. That's why I put on that little tracer head to it, so I can see exactly what's going on with the graph. So just like in the last unit, we use our table to figure out, all these calculations instead of inputting one by one. So we're going to go back to second window, do table setup, and I think we should set it up like this. Table start at 0, and that delta table, the increments, is going to be 15. So it's going up 15 degrees at a time because our theta are in degrees. We're in degree mode. And then you can see the R values. I even show you what it looks like, and you can hit second graph table to see all that what you can do. And if you want to see more, you can just scroll up and down to see more theta values. So I don't think mine is set up, so I'm going to do second mode to get out of here. Second table setup. See, mine is at 0 or -3 because that's what I was doing when we were using sequence mode. I might want my delta table to 15. Keep everything on auto. I hit second graph, and I see all those values, and we're going to work with some of those today because we're going to be doing some graphs. So now we're going to hit the window key, because when we hit that zoom 6 standard, it set up the window for us automatically, and then we hit that zoom 5 square, which actually modified that window a little bit more. So I'll show you on the calculator that it actually, when we hit the zoom 5 and zoom 6 and zoom 5, we got this window, and all these things mean something. Some of them you might be used to, but some of them are new, especially the first three. Those first three are new. So what does X min, X max, Y min, and Y max stand for? They stand for exactly the same thing as before. They are what the minimum and maximum values on the X and Y axis are set up the grid. This is why we chose zoom square instead of having the X axis and Y axis equal to each other, because the window isn't perfectly square. We changed it so you get a nice square picture. Now the next two are the keys. So the first three you see on a window are theta min, theta max, and theta step. Theta min and max sets up the beginning angle for theta and the ending angle for theta that is going to be used to calculate all the points that need to be drawn. Theta is the input, so it is actually telling what input is being used to draw this polar graph. And theta step will be the increments. So from this example, we're starting at theta equals 0, ending at theta max equals 360, and then theta step means plug in every 7.5 theta. So 0, 7.5, 15, 22.5, 30 degrees, so on and so forth, until you get to 360 degrees. So the theta min and theta max is what I use for my input values, and the theta step is the increment to graph points. The smaller theta step, we'll go through some examples of what happens. So I'm going to my calculator, and I have this set up, and I set it up 0 through 360, and I set it equal to 10, and I'm not going to change anything else in the graph. It's drawing a dot every 10 degrees. If I change it to 1 and hit graph, it's drawing a dot every 1 degree. That's why it's taking a lot longer to draw the graph. Plotting a lot of points. Now the other thing is, I don't want to do this forever. I'll let it go one time around. If you don't want to stop the graph from graphing, well, you hit the enter key, it'll pause the graph. Hit enter again, it draws it. If you hit the on key, it stops the graph from working. Let's play with theta max. Let's go up to 1,000 degrees. And we'll make our theta step not 1. That was way too slow. Let's make it worth 15 degrees. And you're going to see it's going from 0 through 15, 30, 45, and it keeps on drawing until it gets to 1,000. And you notice it's a little bit rougher, a little bit more jagged. If I make this equal to 30 degrees, that means I'm going to draw a dot every 30 degrees. And what it does, it connects the dots with lines. So this is every 30 degrees. And look what has happened. It's actually only drawing a hexagon, because this dot here is at 30 degrees, 60, 90, 120, and it kept on doing it over and over and over again. And you can play with it. let's go to 10,000 degrees. Let's draw a dot ever. Let's do 54 degrees. Just something a little bit different. I haven't changed my formula. It's still basing 8 sine theta. But because those only draw points every 8 degrees. Well, I'm going to stop this because I don't want it going forever. Let's try something, again, weird. Let's do 42 degrees. A graph. It's still doing a circle. And you get nice little patterns. But don't be fooled that it's a different equation. I'm just drawing this because I made theta step into something weird. And if you want to go back to normal, just hit zoom 6. But because it's negative 10 to 10, I should always hit zoom 5 to square up the window for me. So it's kind of fun to play with theta min and max and theta step. I just hit zoom 6 and zoom 5. If I think that I need theta step is too big, I'll change it to something smaller, like maybe 5 or 3 to get more points when I think it's necessary. 1 is probably too small. That's a lot of dots. You make theta step bigger, you're going to get less dots. But, you know, it's sort of fun to play with. So now we're actually going to plot it ourselves by putting it into our calculator and using the table. I already have this in the calculator. It's right here is the equation. I could go second graph. I see the table. I'm going to put all this in there. We're only going to round to 1 decimal. And when you want to see more, just scroll your arrows down, and there you go to 160, 180, so on and so forth. I'm going to go back to where 0 is up top. So you have to put all this in to fill out the table. So I completed the table, and I'm going to plot these points. Remember, we're still plotting r comma theta, so it would be 0, 0, 2.1 comma 15. So 1, 2, angle 15. And so 4, so 3 comma 30, here's 4 comma 30, and so on and so forth. So all the pink dots on the graph were from 0 through 180 degrees, and they're all there. And I have to do the ones after 180, and they have a negative r. So how do we do a negative r? Well, we have to go backwards. So when we have 195 and negative 210, I have to go find the 195 line, which is right here. This is the 195 line. Instead of going down 2.1, I have to go backwards 2.1. It's going to be right over that first dot I did before. I go 210, negative 4. Instead of towards 210, I have to go backwards 4, which is that second dot I drew. And what's happening is that all those dots that I drew are being drawn again, and that's why if you notice when I hit the tracer head on the graph, it went around the circle twice. It is drawing each dot twice. So now when I'm done, I actually drew the circle through all those dots, whether they were pink or purple. And if you notice, what did we get? And we should always write down what kind of graph we got. We got a circle, and it was drawn twice over the dots. So let's do the next graph. 6 secant of theta, r equals 6 secant of theta, or really 6 over cosine of theta. They're the same thing. And I'm going to put this in the calculator because, you know, you should try to put things in the calculator first and see what they look like so you have an idea of what you need to do. So here I'm at my calculator. I'm going to delete this out. Let's see. I'm going to type in 6 divided by cosine because I don't have a secant in my calculator. Theta. And we're going to close it out. And I'm already set up for that zoom 6 and zoom 5. And notice what it does. I actually am going to go to the window. I'm going to slow that down a little bit. Maybe the 7.5 is a little bit too fast. Let me go to 3. Because it starts at the x-axis, goes up, disappears, comes from the bottom someplace, and it does it twice. Seems very weird. You know, if I was going to draw a line like that, I would just go from the bottom to the top. But this one, I'll change it. I'll slow it down even. Let's go to 1. Look at this going, starting at the y on the x-axis, going up, 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 disappears behind infinity someplace, and comes back from negative infinity, and is going to do it twice. So it looks like it is a vertical line, and I'm going to go to the second table, and I'm going to complete this table. Again, I'm just going to run out to one decimal place. So I completed this table, and I could draw all these points if I had to, especially the negative ones. So, 0, 6 is the easiest one to draw. 0, 1, 2, 3, 4, 5, 6 is right here. But even like here, 180, negative 6. Well, 180 is the positive direction, so I have to go backwards, negative 6. That's why I get the same dot again. I'm going to draw the 45. 45 is 8.5. Well, if this is 10, then this is 8.5. And I could do the 135 with negative 8.5, which would be backwards, but I like the positive one, so I'm going to do 315, 8.5, which is right around here. And then I realize it is just, let's see if it'll work out for me. Not too bad. There is my nice vertical line. Okay, so the next one we're going to do is we're going to be r equals 4 plus 4 sine theta. 4 sine theta will just be the circle like we did earlier, but this is 4 plus 4 sine theta, so it's going to be a little bit different. It's going to be circular, but it's not going to be a circle. So I go to my calculator to help me out here, and I put it in here, and I've already set it up. I've done my zoom 5, zoom 6. I'm going to hit graph. We get this little weird looking shape. It's called a cardioid because it looks like a heart. I can slow it down if you want, but notice it doesn't draw it twice like it was drawing everything else twice. It was only drawing once. But I'm going to use my table, and I'm going to copy these onto my table, and I'm going to plot some points. So I completed the table. Hey, no negative r's makes my life a little bit easier, but now I have to draw some points. So I'm not going to be able to see both so well, but you have to do it on your paper. I'm going to bring this up, and I'll do it in pink again. First point was 0 degrees was 4. 1, 2, 3, 4. At 15 degrees, I was at 5. At 30 degrees, I was at 6. And so on and so forth. I've drawn all the dots up through 180 degrees. Now come the harder ones. Well, 195 is at 3, not so bad. 210 is at 2. 225 is at 1.2. Kind of have to guess at it. The next dot is 240 and a half. And there's no way I'm going to be able to draw that 0.1, so I'll just draw the 0. And I do the rest of the dots, and now I'm going to draw my cardioid the best I can. And there's my cardioid. If you play with those numbers that were the 4 so that were in front, you change them differently. You made them 5 and 5, or make one bigger and one smaller. You get different looking things. And the last one we're going to do is r equals 5 cosine 3 theta. And notice that I put a number in front of the theta. I think that's going to play with this a little bit. I'm going to have to change my table. We'll get there in a minute. I'm going to use my delta table as 10 instead of 15, just because of the way the numbers work out. And I go to my calculator. I already have it in there. And 5 cosine 3 theta is in there. That's not 30, that's a 3 theta. I'm going to hit graph, and look what we get. If you want to slow down a little bit, maybe try 3. This is called a flower graph. It's drawing a 3-petal flower, and look, it drew it twice. I'm going to play with it. I'm going to come back to this. But I want to show you what happens if I put a 4 in here instead of a 3. Is it going to draw 4 petals twice? No, it's actually going to draw 8 petals. So if the number in front of theta is even, it's going to draw double as many petals. If the number is odd, it's going to draw that number of petals, but twice over. Let's go back to the 3 one because that's the one we have to work with. Here's our graph. And actually I want to see the table. But I changed my delta table, so I have to go to my table and go second window. It changes delta table to 10, not 15, because that's what's needed for this problem. And then second table, and I could take all that information and put it on the table on the piece of paper. So you see I completed the table that I got off the calculator. A lot of 2.0s, 2.5s, 4.3s, and 5s, some negatives. Now I could draw the graph of all this. I'm going to move it up so I can see everything. I'm going to make it nice and big. Do it in pink. So the first point was 0, 5. Well, this grid is 5, so that's 0, 5. At 10 degrees, I was at 4.3. So at 10 degrees, it was 4.3. At 20 degrees, I was at 2.5, 4, 3, 2.5. And at 30 degrees, I'm back at 0. Now we have to do 40 degrees and negative 2.5. So 40 degrees is here. So backwards would be 220. So right here. And then 50 degrees, which would be 230, was at 4.3. And 240 degrees is 5. Or 60 degrees is negative 5. 70 degrees is at negative 4.3. 80 degrees is 2.5. And we're back at 0. And you're starting to see some of the petals. Like here, you could see this one petal has really developed so far. I'm going to do the rest off. And you can see I drew the rest of the dots. And what's good, you don't have to draw all the dots. Because you know you don't have to draw each dot twice. And you're getting these nice petals that are being formed to the best of my ability using a stylus on a tablet. And there's your flower with 3 petals. Why? Because it was a 3 theta and it's drawn twice.